Hello. So my name is Dennis Borger. I work at Saxion University, applied university this. I'm going to also present ourselves a bit here, what we are doing, and why we are using also ROS. I think that's also good to know. We are part of the Applied University of Saxion. It has currently around 28,000 students located in the east of the Netherlands, Enschede, Deventer, Apeldoorn. And it is, most of the technical courses are in Enschede. And besides the normal curriculum, so we have like 68 bachelor programs, 7 masters, and 3 associate degrees. But we also have applied research groups, and that's kind of, in the Netherlands, I think quite unique, and that is that we are doing a lot of demand-driven applied research. And what that means is that we take a lot of technical papers, scientific papers and research, also from the University of Twente, which happens to be in the same place, and get papers out of that. It gives new scientific insights, but the companies themselves, also in the Netherlands, are not always big in terms of R&D, and they have troubles to get these new insights into production. And that's why we help here. So we try to get new knowledge from the fundamental research, try to apply that, and by doing that, we are helping the smaller companies, so we get this practical knowledge towards the industry, and practical questions we get back from them. And why we are also doing that is to help also our own higher professional education to also adapt the bachelor program in terms of the new insights. So it's like a cross knowledge exchange, basically what we're doing, I think, for the last 10 years. And it gives also human capital. So we also deliver human capital to the industry, obviously. We as a research group have been established in 2013. Currently we have more than 50 employees. We have 300 students each year in our research group, which means graduate students, internships, minors, all kinds of practical challenges. We have 140 partners. We're doing currently more than 30 R&D projects a year. And we have like a turnover of 4 million in 2024. And the team is below. We have a tendency to work and collaborate a lot with the SMEs inside our own region. But also we try to get more a partnership collaboration also in Europe within the Horizon 2020 projects. A lot of partners, also public, non-public. We are doing different types of control. We have 2 main lines, basically unmanned systems, which is doing navigation, and the other one is the industrial projects. And on the side note, we are doing a lot with the police, other research institutes, but a lot of companies as well. We have all kinds of lab facilities. A drone dome, a first drone dome in Europe. At least you can fly within the building, but it is outside. So we can just use all the GPS, RTK, and all kinds of technologies there, but also simulate the real weather. We have a digital twinning. We are having robots on lakes. Lab environments, and a lot of bin picking applications, robotic arms, that kind of stuff. These are kind of our projects. We are doing apple picking, a lot of agro projects as well. So I saw, I think, a video from IGUS. We have also used an IGUS once with a company in the region to do the apple picking. Here is a firebots, but also in the unmanned we are doing a lot with drones. So You see there the mega rescue drone. It carries a person of 90 kilograms, and we are designing these drones ourselves. So also in terms of control. So a lot of control as well. So, but in most of these projects, ROS is also involved. First use case is the robotic bin picking. Yeah, the challenge here is that we would like to participate in projects with digital-driven manufacturing, and that is like high mix, low volume production. That is a way we can compete also with other countries in the world, so to say, to be still proactive there, also in the to produce small batch sizes. We would like to be flexible, so high quality and good solutions. And we would like to use modular software, so this project is about modularity and also robustness. So these are the two things that were the major part of this project. And we would like to do modular bin picking with different types of cameras, interchangeable, also with different types of frameworks. So one AI framework we have used there, and another classical computer framework, which is used by, we used Open3D for that one. And the main thing here is that we would like to bring ROS2 and AI closer to the industry. There's a lot of hesitation. There was this presentation from Siemens a couple of presentations back, and he was mentioning, yeah, it's always difficult to integrate both worlds. And sometimes you see that, like Voortman Steel Machine, it's a big company. They are doing the path planners, everything themselves. And they're hesitant to use like ROS for that to do the path planning. But we are interested in to see if they can leverage that, those tools, path planners from MoveIt, for instance, into their own production systems and see if that might work. Also on the classical computer vision, but also for the AI solutions. And as a side note, we have also taken a look at real-time control here, but I'm not going to go into that. Results achieved, basically it should be modular. So by using, the intent was also to use also another arm, a robotic arm. So we also ordered a KUKA for this, or at least Voortman has done that. But we did not have the time to finalize that. But we are starting the effort, so I will get back to that one. But for this one, we have 3 use cases: the metal sorting, and that is on top of both. Normally those metal plates are coming in Euro pallets, and they need to be distinguished again on the production line to go through intelligent transports to the, I should say, to the for buildings, basically, to have a proper planning. So they developed that in CAD. They are going to be produced, and then they need to be sorted out again automatically from Euro pallets. And the other 2 is fruit handling for Rewo company, to do bin picking with apples by using a vacuum suction gripper. And the other one is a 2-finger gripper from ROBBOtic. The thing is that we would like to change the grippers. So 3 types of grippers, but also different types of cameras. So we use a Ziffet 2, and we have had also a Wingler camera from Voortman, Intel RealSense, and a Z. And we would like to do that within as little as possible software modifications needed to have this deployed. And what was needed for that? Well, we have here 2 solutions here. You see on the right-hand side the approach that we have done for Voortman, the steel plates, and that was for these steel plates, you need to fetch them because they have holes in it. You need to have also, you need to take the center of gravity into consideration as well. But also these plates are stacked upon each other, and then the question is, can we use the Ziffet camera based with point clouds? How can we differentiate the different steel plates there from a bin picking kind of problem? On the other hand, we have used SEM6D and foundation pose as a CAD model. You can enter here in the AI framework to fetch other type of of products like apples, which are not structured objects, so to say. For this one, it was, for Fortman, because they would like to have a robust solution in the end. And then the thing about AI is that robustness is still difficult to achieve. We decided, well, let's go into a dive on new frameworks for point clouds. Open3D is also in existence, I think, for 2 years now. It's in the beta currently. And we try to use also new technologies in that area. So for these two different types of use cases and different types of objects, so one, we use the foundation pose, and on the other hand, Open3D. And based on this one, we would like to get the pose from it, so to fetch it in the good position and orientation. Same for the AI framework. So in the end, we need to grasp like objects from a bin, either way apples or steel plates by using a complete pose. Also, for the grasp, we needed to handle different types of grippers, like here's the Schunk, Festo, and the ROBOtic, and how to exchange grippers within ROS also easily without changing a lot. So it was all about modularity, so easy camera switching. Also, path planning was part of that because we have used different types of path planning algorithms. I'll get back in the other presentation as well for this one. Robotics arms and end-effectors, and integration of multiple vision approaches, conventional AI-based, and flexible grippers. Code repositories will be made available for you guys. In the end, what we have achieved is we have developed a flexible system with interchangeable components. So both frameworks were up and running. The thing about AI frameworks is it provides an 80% solution. I have talked, I think, during a coffee break with someone who said, yeah, 80% is not enough. No, that's correct. So talking about robustness, AI still has work. Yeah, we still have a lot of work to be done in that area to get a good pose to actually grasp these kind of products. We use state-of-the-art NVIDIA Foundation pose, Sim60, we have taken a look at that, and we have integrated that also in ROS, and ROS2. And we were able to grasp it with an UR5. Currently, we are busy also implementing this on ABB, the 1100 platform. And from the Open3D perspective, so from the perspective from the classical computer vision, we can say that it was robust. So for that application, we achieved, the company was also happy with that. So it was new, they did not know about that solution, and they are going to put that also in practice on the real machine. So that one was a good achievement. For the AI, everybody is like still hesitant to actually use it. I think I can show some videos. I will. So it's scanning here. You see that it is scanning. It scans the area. You see here the point clouds appearing on screen, basically as one point cloud. Now we are going to combine 3D, Open3D with classical computer vision techniques like the object for the correct position estimations. That is to find the plates, and now we need to identify which plates is on top of each other to get a good, proper pick location. And that is by determining relative cluster positions, basically, of the steel plates. Steel plates is still difficult because it's also reflective, so keep that in mind. And that was also a struggle for us to work around that, but we also achieved by proper light conditions to actively solve that, and then you can actually put also the object in the correct category. So classification is also being done here. And then it just continues, so it goes to the resting pose. It is going to do a scan again, and then we can continue with with the other plates as well. Well, to make it robust, it needs to be speeded, basically. So that's kind of the thing that we can take a look into. And on the other hand, we have here the same. This is basically the AI. You select the proper object, basically. Apple, well, with a two-finger gripper, an apple is not a good solution, I can say, because it will damage the product. But at least we were able to select different. By using also the vacuum gripper, select the proper object you would like to have. You have the classification in AI there. You select it, it is going to be put there, and you can just pick it up with a suction cup gripper. Currently, we are extending. We would like to also use the ROBBIN for this one. We have also a cobot, GOFA. Currently, ROBBIN robots do not support ROS2 because of the new robotware. They are using a new HTTPS REST API for this one, and it is not part of the. I think Picnic Robotics has back in the days put a pipeline, but that is only using for all the versions of robotware. So new ROBBIN robots, you will definitely end up with these kind of problems. Also some, we are currently having some communication issues, so that is the real-time thing. This morning was also discussed by Kuka, and we also have, because a lot of students are also going to use that, is that it needs to be in the auto mode, so there's no deathman switch. For a cobot it's fine, but for a robot it's not fine because it will just harm you. As you can see here, there's a GOFA, a new one. We are currently controlling it from ROS, but we still have issues here. So I would like to invite you to collaborate. I will send you also a link there. Another thing, everybody is discussing that already, this behavioral trees. We also start to use that for tomato picking. Here you see that we have developed a special gripper to fetch the tomatoes safely from a plant, and it's using a new behavioral trees within ROS. So we have extended this as well. So that's part of the things we are also currently are doing. And we have another project, and that is the ScanPlan Pro, and it's done with a lot of smaller companies in our area. It was Fraunhofer is also part of that from the University of Twente, so that's another department, I think, but it's worth to mention. And what we are doing is that it is SMEs handling with plastic injection, rotational molding, metal casting, injection molding of metals, welding, you have spatters, 3D printing of plastics, and these companies all has kind of use cases. And this was for us the test to do automated post-processing. And why? Because it's a dirty job, not a lot of people are, how should I say, available in the labor market. It can be boring, you don't have a consistent quality outcome, all kinds of issues. So we would like to automate that. And we had a couple of use cases, so the weld line contour grinding, plastic contour cutting, milling, and grinding small areas of steel plates. And this is basically architectural, but there are variations. So materials can change, interaction with the surface is always difficult. The question is also what kind of cut models do we need to use? Movement of tool is not consistent, was also discussed this morning. And are we going to do full or local processing? So we had kind of a research topics in this project as well. We needed to have a look at the sensor selection for scanning. Robot path planning was a very important piece here. Tool selection as well. Also the market solutions, what is out there was part of that. And for ROS-Industrial solutions, we explored scan and plan framework, and that one is coming from the Southwest Research Institute. I think they're also coming tomorrow. We used different types of move with Cartesian, move it with pills, industrial reconstruction with RealSense, and industrial calibration with Zivit. And for the tool path generation, we used Open3D software, which we started with. Well, scanning, you can do that with a line scanner or with a structured light. We have tested that also with RealSense. It was not working with a structured light. So now we are using a single scan, basically by using the Zivit. And then you get contour removal. So here is this line. You need to remove that. You would like to find the normals because we're trying to get the complete pose of that one. And we would like to interpolate to find the waypoints to do proper path planning. And that is what I'm going to discuss. And there's also a call for, we have some questions there still. So we would like to get into a follow-up project here. And it is also based on the tool geometry implemented in Open3D. For the scan and plan, it's simulated over here. Currently on the demonstrator, so for the scan and plan, we could only do that with the Zivit camera in simulations because this framework is using Tesseract, including the Descartes path planning tool, and we had issues with it. Tesseract is not documented very well. We had some issues with that, and with Descartes, I will come back to that. Why that is kind of a solution for us. For the operator currently on the demonstrator, we are using OpenML, and OpenML is just a pathfinder in free space, A to B, without any intermediate waypoints. So that is a thing because we have multiple waypoints here. So in MoveIt, there is the Cartesian space, the Cartesian planning framework, which is using OMPL. But we find out that if you use that, and you have in the I is 1 and the I minus 1, you had a collision in between. The inverse kinematics recalculation does not work, and the path planning is stuck. And that is something we experienced with the first solution. So for the planning, it was not so robust. So we tried to go to pills, path planning, for trajectory as well. But we found out it had the same issues. It was only a bit quicker. But the thing is that if you have, it only has a collision detection, but not a collision recalculation, so path recalculation. So these kind of things, it did work on our demonstrator, but we had some issues with that sometimes a valid path could not be found anymore. So we would like to do new research, we were having a look at the Descartes, and Descartes was part of MoveIt 1. And in MoveIt 1, it allows you to create from your trajectory multiple waypoints with multiple inverse kinematic points. And we were able to actually get nice path planning with this one. But in MoveIt 2, it is not available there. It's only in Tesseract. So we need to have the question, well, perhaps it's good to have this one back inside MoveIt 2. But yeah, that's the question we are also going to have a look at. For the MoveIt task constructor, it is better to do this for bin picking solutions. It's kind of quick. The bio-inverse kinematics and pick, it was too slow. It will already also find out. Yeah, and we also have other type of path planners in MoveIt, which is Chomp and Stomp. Stomp is not available in ROS2 Humble, and Chomp is currently, we had some issues with that because it is doing its planning in joint space, and we were having issues with that. So we had to deal with path planning failures a lot. The hand-eye calibration is done with Zivit's own calibration model. Collision checking of tool was not right, so we need to have a look at that. I can show you also the video of it. I think it's moving. Yeah, and also the non-vertical tool orientation was not working well. So that's also something we need to find out. We haven't used the robot force mode yet from Universal, so that's something we would like to use, also for the follow-up project, basically. And yeah, basically the application industry, yeah, some market solutions are found. So there are some things there, but the same for the ROBBIN project as well for Scamp and ProIS. Can we bridge the gap of do the advanced robotic solutions that are available within ROS to make that more applicable for SMEs? Because for us it is still, because we're working a lot with SMEs, with the R&D for these companies, but it is a lot of manual work still, and I think we can do still better. Yeah, and we are not doing only industrial applications. We have also a drone here. It's only developed we develop our own drones with our multiple control, and this is for the firefighters. So you can see that it's kind of nice things. It is using also ROS, so that's something besides for the unmanned systems. We're also doing that there. So we develop our own drone platforms with the controllers as well. Because you have lots of dynamics here, because there's a water tank down below and you need to compensate all the downwash with it to extinguish fires. That's something I just want to show. I think that was it.